Ladies and gentlemen, welcome back to Slingshot CPA series, session 5. We will be covering the installation of Kubeadm, Kubelet, and Kubectl. These are the packages, and we're on the Kubernetes documentation website, by the way. And I want to make sure that I'm on the master node first. There you go, I'm on the master node. So we will be installing these packages on all the machines, by the way. So we're starting with master node. Kubeadm basically is the command to bootstrap the cluster. Kubelet, of course, this is the component that runs on all our machines in the cluster and does things like starting pods and containers. And Kubectl, the command line utility to talk to the cluster. So let's take a look at the exact steps that are needed for us to get the packages installed. So if you have noticed a slide that I shared with you in the previous channel or the previous session, you would see like 5 steps where you would update packages and then install the Docker runtime. And then we again install the packages that are required for all the indexes to work properly, the package indexes. And we also will download the GPG key as shared here, like a Google public signing key. And then finally, we will install the packages for Kubelet and Kubeadm and Kubectl. By the way, the only difference between the Kubernetes documentation to the documentation that I shared with you in the previous session is that we are using a specific version, Kubeadm 1.19.1. So make a note of that, and I'll show you to you now as I walk you through. Again, you don't have to memorize any of these commands since they're already available online. I would be simply copying and pasting these commands. As you can see, the procedure is quite simple. We have updated successfully the package index. Now we will install the certificates and proceed further. So copy and paste the CA certificates for app transport. And that's done as well. I will now be downloading the GPG signing keys for our Then the next step is to add the Kubernetes apt repository to the system, which is a simple one-liner. Just copy and paste that command. Let's do the apt update again. Now, next command is where I would be installing the packages for Kubeadm and Kubelets. And this is where we have to be careful. So I'm going to be pasting the command exactly the version that I want, and then hit enter. So it basically installs all the packages for version 1.19.1. And that's what we want. Okay, so with that, the installation is done. Now let's spin the version by doing sudo apt mark hold kubelet kubeadm kubectl. This will pin the version. So when you upgrade next time, you have to unhold or unpin and then install the new version or upgrade the new version. The other most important thing is installing the Docker container runtime. So I'm going to pick the Docker container here. So I've installed that now. Okay, that's done as well. Okay, so moving on to the next step, let's make sure we know the IP address of the host. We're looking at ENS4 on this virtual machine, which is 10.2.18. Let's copy that IP address and make an entry into etc hosts file. Insert, paste. Then we'll give it a name as K8's master, and let's save that file. Okay, so there is a problem here because we logged in as, and we need sudo to make sure that we have the permissions to write to that file. All right. So that file is saved. We're good to go. I think the next step is pretty straightforward now, installing the control plane components. Now that we have the host ready, so we will move on to the creating the cluster with this as the next step. So I'm going to bring back my slide that I shared with you in the previous session. We would be going over the 3 or 4 core steps here. So primarily, we will have to download the calico.yaml from the link here. And then I've already shared with you the cluster.conf YAML, which basically dictates specifies the Kubernetes version that we want to use, and then what is the name that we have given for the control plane endpoint, and the part subnet 192.168.0.0. So this subnet IP address is coming out of the calico.yaml. So keep that in the mind, and then I will quickly share with you how we can use it cluster.conf and in the flag for Kubeadm. So when we do Kubeadm init -config flag, we would pass the config cluster.conf.yaml to it, and that will take care of the installation of the control plane node. Okay, I made sure the cluster.conf.yaml is there on the system now, and it's another step is basically to copy the calico.yaml to the local machine. Now you can see the YAML is here. That's the network add-on module for pod networking. We will be able to go into calico.yaml and find out the address range that I was referring to. So you can see this is the value that we're looking at. The default IPv4 pool to create a startup if the none exists. Pod IPs will be chosen from this range. So changing this value after installation will have no effect. So this should fall within the cluster cider range. So that's why this is where basically the pods will communicate with each other, and those pod IPs will be chosen from this range. I would be a little bit careful here. I will come out of this calico.yaml without it saving and making any changes to it, because this is the file that we will use as a manifest to apply to the Kubernetes cluster to get the network add-on set up. So we're now ready to initialize the cluster or the bootstrap the cluster. I have actually copied and pasted the command here, as you can see. Kubeadm init config equals to cluster-conf.yaml. We're uploading the certificates, and then we're outputting all of the installation steps that you're seeing here, the output, into a file so we can reference that after the installation. So guys, control plane has initialized successfully. This output is very, very important for us to see from here onwards all the way to the bottom. And it has done a lot of updates, installs, and package downloads, and created static manifests, created static pod manifest for all the API server, controller, managers, schedulers, and then it also uses this folder for keeping all the manifests for the core components. And all of the control components seems to be healthy there, so the cluster was successful in terms of installation. Now, what we need to do is, since we are the regular user and not the root user, we would simply copy these commands one after the other here to get the access to the cluster. As I was mentioning, installation is not that hard. It's pretty straightforward. All you have to do is, and by the way, so it also talks about now you should now deploy a pod network to the cluster. So what I would do is now at this point of time, I would have a privilege to apply the calico.yaml to the cluster. So there you go. It's creating all the CRDs, the custom resource definitions for different components there, extensions, and it's pretty much done. So the next step here is we should be able to join any number of control plane nodes running the following commands. So this basically spits out the Kubernetes master with the token and hash that we can use to join more control plane nodes. If you remember, I was talking about if you would like to play around with the high availability or disaster recovery type scenarios or strategies, then you should be able to proceed with that option, copying this command here. However, for the examination preparation for the labs that we will be running, we would not need that. What we would need is we simply can join any number of worker nodes, right? This is the command that we would need. So what I'm looking for here is the token, which is this. Again, remember that within 2 hours, if you don't join a worker node, you will have to recreate the token and the hash for new worker nodes to join. So after 2 hours, these values will expire. Hope that makes sense. Now we're moving on to the next step. The master node is ready. All we have to do is get the worker node running. If we do kubectl get nodes at this point, you would see the Kubernetes master being ready with the version that we wanted. It's also available. You can even describe the node or to get more information about the. So this talks about like what all components it has installed, kube system in different namespace, in namespace and all different parts running here. The CPU and resource limits, as you can see, and then also if there's any event, if there is any abnormal event, you would be able to find out here. But it looks pretty much everything seems to be pretty healthy here. Again, this is the description of the node for the master node. One thing that I would like to point out to you guys that right now this node is not tainted. So if you create a, so by the way, it is tainted. So no schedule, that means you cannot deploy the parts on this one. So let's create the worker node and join the worker node to the master.